In this video, we're going to look at the biochemistry of fight or flight. It's important you understand the mechanism of what actually happens in the body during a stress response so that you can learn to recognize and correct it. When someone perceives the first hint of a stressful event, the reptilian brain or brainstem is stimulated. This part of the brain is over 400 million years old, and yet it remains structured into the anatomy of a human brain today. It controls vital involuntary functions such as motor movements, breathing, heart rate, blood pressure, body temperature, digestion, growth, and your immune system. Its primary concern is your physical survival. The reptilian brain has a command center called the hypothalamus, which, during stress, sends signals to the brain's pituitary gland. This then signals the adrenals to produce the stress hormones adrenaline and cortisol. These stress chemicals are released into our bloodstream and can flood our system in a split second, causing our whole system to go into a highly aroused, hypervigilant state. If the brain continues to perceive stress, the body stays revved up and on high alert. So the reptilian brain triggers a chain reaction stress response in 3 parts: the hypothalamus, pituitary gland and adrenal glands, commonly called the HPA axis. The release of adrenaline and cortisol are essential in the stress response and bring on a number of dramatic physiological changes. The response is so efficient that the reptile brain starts this sequence of changes even before you've had a chance to process that there's a threat. That's why people can do things like jump out of the way of an oncoming car even before they think about what they're doing. Adrenaline and cortisol make our blood pressure go up and heart beat faster. Our breathing becomes more rapid and airways in the lungs open wide so that they can take in as much oxygen as possible. Glucose and fats are released into the bloodstream and the blood is diverted away from our skin and digestive tract to the muscles and limbs, which are energized by the oxygen, adrenaline and glucose. This causes the muscles to tense up and become charged springs ready to run or fight. Your legs may shake as they're prepared to run. Your hands may shake as the muscles of your arms are prepared to fight. Even the tiny muscles attached to each hair on the skin contract, making the hairs stand upright and cause goosebumps. Skin blood vessels constrict, causing chills and sweat, cooling the body and giving your palms and feet a better grip. Less blood in the skin also causes any surface wounds to bleed less. The reptilian brain receives priority blood flow, increasing alertness and allowing fast instinctive reactions. Hearing and other senses become heightened. Our pupils dilate to let in more light, sharpening our vision, ready to relay signs of threat to the brain. We may experience tunnel vision, enabling us to focus on the danger point. The spleen contracts, pumping out white blood cells and platelets in preparation for possible injury, and blood clotting increases to prevent excessive bleeding. The bowels and bladder may release their contents, and you may feel like vomiting. This reduces the need for other internal activity and lessens your weight, so you'll be lighter to run from the threat. You're also less appetizing as a potential meal. The stomach and intestinal tract tense up, and saliva decreases as the digestive system slows. You don't need to be digesting lunch when you're about to become lunch. Far better to have the energy the digestive system uses to be able to fight or run from the threat. So under acute stress, fear unleashes reserves of energy that normally remain inaccessible. We become in effect superhuman. We've all heard of mothers lifting cars off their children. It's the biological equivalent of opening the throttle of an engine and can only be done for short bursts. As you now understand, your continuous low-grade production of cortisol and adrenaline raids the body's energy reserves and totally depletes resources. It's no wonder you're exhausted.